Hi everyone, what's up? Welcome back to my tutorial channel. Daniel's here and today I'm making this video to continue working on basic annuity. And today objective, firstly I'm going to introduce deferred annuity, then annuities with block payments, perpetuities, and some trick to solve some problem concerning annuities and perpetuities. So let's get started. Deferred annuity. Remember on the first lesson of annuities, I showed you how to um, evaluate annuity immediate and annuity due. So annuity immediate, the first payment is make at time 1. Annuity due, the first payment is made at time 0. What if we have an annuity due or an annuity immediate that the first payment is made at a different time? So let's consider this annuity. Consider the following series of payments. So here's an annuity in which the first payment is made at time 3. So this is not the simple annuity due or annuity immediate that we learned in the first lesson of annuity. So here, how do we find, evaluate the present value and the accumulated value of this annuity? So suppose you consider a time 2. If you look at time 2, this annuity is basically an annuity immediate because the first payment is start 1 year from the day the annuity is made. So at time 2, this is basically annuity immediate. At time 3, this is basically an annuity due, right? So we are going to determine the value of this annuity as of various days. So at time 2, the value of this annuity is basically A7, the annuity immediate. At time 3, it's just an annuity due. At time 9, it is the accumulated value of annuity immediate. And at time 10, the value of this annuity is basically the accumulated value of annuity due. So that's how we determine the value of this annuity at the beginning and at the end of at the day of the first payment or at the last day the day of the last payment. So what if you want to determine the value of this annuity at different times, suppose time 0, time 11, or time 12? So remember on the lesson of time value of money, I have shown you how to bring money from this time to the other time. So to evaluate the value of this annuity at time 0, we basically bring the value of this annuity at time 2 to time 0. So at time 0, it's v squared a7 because we bring the value of this annuity from time 2 to time 0, so we multiply this amount with v squared. And similarly, if you bring the value of this annuity at time 3 to time 0, you have to multiply v cubed, and similarly for s7 and double 7. So that's how you determine the present value of an annuity with the first payment start a different time. Or if you consider time 11, the value of this annuity is basically A7 times 1 plus I to the 9 because you bring this amount from time 2 to time 11, so you move forward 7 steps. And similarly, you have 1 plus I to the 8 times A double 7 and 1 plus I squared at 7, 1 plus I at double 7. So that's how you evaluate the value of an annuity in which the first payment start at different times. So however, if in the exam you are given this question, if you start writing these formulas, it's gonna be confusing. So we are going to I am going to introduce another formulas for this annuity. So we start with a new notation. So here I'm going to use this notation 2 plus A7 into I. Here I ignore I because usually with the same effective rate of interest I don't need to write I. So this notation means an annuity immediate start at time 2 has 7 payments. Or another way to read it is just like an annuity immediate deferred at time 2. So it's basically to go to time 2, pay what the symbol to the right of the vertical line says. This is the vertical lines. So we go to time 2 and pay what on the right side of the vertical line says. So on the right side of the vertical line here, it is an annuity immediate of 7 payments. In general, a deferred annuity is annuity in which the payments start at random time then 0. So we have two notation here. The first notation, M plus AN into I, that means we go to time M and pay an annuity immediate of N payments with effective rate of interest I. And M slash A double dot N into I, that means we go to time M and pay an annuity due of N payments with effective rate of interest I. And we also have connection between deferred annuity, immediate and due. So here M slash AN into I is the same as M plus 1 slash A double dot N into I. And that is the same with V to the M AN into I. Because we bring the value of this annuity immediate from time M to time 0, so we have to multiply with V to the M because this annuity deferred at time M. And this is the same as AM plus N into I minus AM into I. So in deferred annuity, we have learned 3 more important formulas. One more important formulas with 2 more notation. Now we continue. Now we talk about annuities with block payments. So from the beginning of annuities up to now, we have learned only the annuity in which the payments are equal. That means the payments are fixed. So what if we have an annuity that the payments are different over time? For example, the first 10 years, you make payments of $10 at the end of each year. The next 20 years, you make payments of $40 at the end of each year. So the payment is kind of level up or level down. It's like the payment are level over periods of times. So that is how annuity with block payments is constructed. So an annuity with block payments is an annuity in which payments are level for a period, then change to another level for another period exactly. For example, we look at this time diagram. This diagram illustrates how payment with how an annuity with block payments work. So you see on the first periods, we paid this amount at the end of each year. But in the second period, we increase the amount of payments. Then at the third period, we decrease it a little bit. And then at the last period, we increase it until we finish the annuity. So let's consider this example. Consider the following annuity with block payments: $5 for the first 8 years, $12 for the next 7 years, $15 for the next 6 years. This is kind of an annuity with block payments. And here's the time diagram. From time 1 to time 8, we pay $5 at the end of each year. From time 9 to time 15, we pay $12 at the end of each year. From time 16 to 22, we pay $10 at the end of each year. And from time 23 to time 28, we pay $15 at the end of each year. And our main goal is to evaluate the present value and accumulated value. So here for annuity with block payments, we have two methods, the long way and the short way. So in this video, I'm gonna show you two ways, the long way and the short way. However, on the exam, I suggest you to work on the short way because it's help you saving time a lot. Because the long way is it's easier to understand, but it takes longer. So now we start with the long way. Reconsider that problem. From time 1 to time 8, we pay $5. From time 9 to time 15, we pay $12. From time 16 to 22, we pay $10. From time 23 to 28, we pay $15. So the long way is basically we are going to break this annuity block by block, and we are going to find the present value of each block at time 0, and then we add them together. So for the first block, the present value of the first payments is basically an annuity immediate because the first payment start 1 year from time 0, and we have equal payments. So this is 5A8 in July. And then the second payment is basically just a deferred annuity, right? It basically just a deferred annuity because it deferred at time 8, and this is an annuity immediate of 7 payments. So present value of the next 7 payments just 12, 8 plus A7 in July. That means an annuity immediate of 7 payment, therefore at time 8 with $12 for its payment. And remember, in deferred annuity, we have learned one more formula, that is M plus AN in July is AM plus N in July subtract AM in July. So we apply to this. So we have 12 times A15 in July minus A8 in July. 15 here is from A plus 7, and 8 here is right here. So we have finished the second block. Now we continue working on the third block. So for the third block consists of 7 payments, therefore at time 15. So this is another deferred annuity, therefore at time 15. This is an annuity immediate consisting of 7 payments. So we have 10, 15 flash A7 and July, and apply the formula of deferred annuity. We have 10 times 8, 22 in July subtract A15 in July. Now we continue working on the last 6 payment, the last block. So this is the last deferred annuity, deferred time 22 right here, because the payment 15 start 1 year from time 22. This is annuity immediate. So 1522 plus A6 in July, there's a 15A28 in July, subtract A22 in July. 28 here is from 22 plus 6. So now we have finished the present value of each block payments. Now we are going to add them together because all of these are the value of the blocks at time 0. So the same time, so we can add them together. So therefore, the present value of this block payment annuity is 5A8 in July plus 12A15 in July minus A8 in July plus 10A22 in July minus A15 in July plus 15A28 in July minus A22 in July. So basically we add all of these 4 terms together, and you see here we have many items are identical. So we are going to simplify this formula, this equation. You see that we started A28 because A28 we have only one item. So 15A28 in July. Then we go to A22. So we have 10A22 here with negative 15A22 here. So we have negative 5A22 in July. Then continue with A15 in July. We have 12A15 in July minus 10A15 in July. So you have 2A15 in July. And the last one is 5A8 in July subtract 12A8 in July. So we have negative 7A8 in July. So that's how you determine the present value for an annuity with block payment using the long way. So now we are going to work on the short way because imagine if you have a problem with 20 block payments and you continue working like this, one by one you're gonna have like 20 lies, and then you keep wasting your time on the exam. So now we go to the short way, the shortcut of this problem. So for the short way, we see that this payment we start 5 and then increase and then decrease and then increase again. So suppose at first we assume all of these 15, then we subtract 5 for the next, and then we add 2 again and we subtract 5. We are going to have the same annuity. So we start with the last 6 payments, and we are going to make these 15 the 28 payments. So we make this is 15 with 28 payments. So 15A 28. So that is for the first 6 blocks. Then we consider from time 22 backward. You see that the amount is decreased by 5. So we take this amount, subtract 5 times A of 28 minus 6. Like you take 28 here, subtract 6. And continue, we use this amount subtract with plus with 2, because from 10 to 12 we increase it by 2. We increase the payment by 2. So the next 7 payment is $2 higher than 10. So we use this amount and add with 2 times A of 22 minus 7. 22 minus 7. You see that? And continue to the last block. You have the first 8 payments. You subtract 7A 15 minus 8, because from 12 to 5 is decreased by 7. So this is how we work on annuity with block payment using short way. This is for calculate the present value. So this is the present value. So what about the accumulated value? For present value, we start at the last payment and then moving backward. For accumulated value, we start at the first payment and moving forward. So here's how we make accumulated value. First, we start with 5 because we start at the beginning, and then we make these 28 payment become all $5. And then from 5 to 12 is increased by 7, so you have to add 7, and it's continue with the next 22 payments. And then from 12 to 10 is decreased by 2, so you have to subtract 2 for the rest 15 payments. And then from 10 to 15 is increased by 5, so you have to add 5, and this apply for the rest 8 payments. You see that? So that's how you determine annuity deals and annuity immediate. Annuity with block payment using the short way. So in the exam, I suggest you use the shortcut, because the long way the long way is worth 5 if we have only 2 or 3 blocks payments. But if we have more blocks, the problem gonna be long for you to work using applying the first way, the short or the long way. Okay, so now we are going to a new annuity, that is perpetuities. So in annuity during an immediate, we have learned the payment. Those are annuity with end payments. Like we have end payments. Suppose we have 10 payment, 20 payments. What if the payment continue forever? Like if we have an annuity that we are pay $1 at the end of each year and keep paying forever, never finish. So that is an example of perpetuity immediate. And if we have to pay $1 from today and continue paying forever, we have a perpetuity due. So first, perpetuity immediate. A perpetuity immediate is an annuity immediate with annual payments of $1, where the payments continue forever, like forever. We never stop paying. So basically, you take limit using annuity immediate. So annuity perpetuity immediate is notated by a infinity angel I, and this is by we taking limit n go to infinity of ANI. This is annuity immediate. So remember the formula for annuity immediate we learned from the last lesson was 1 minus v to the n over I mean immediate. So you remember v is 1 over 1 plus I, so v is less than 1. When n go to infinity, v to the n is basically go to 0. So the limit of v to the n is 0. So the limit of this amount is 1 over I. So the price of an annuity of perpetuity immediate is 1 over I if we have $1 for its payment. And we have perpetuity due. Perpetuity due is an annuity due with annual payment of $1 where the payment continue forever. So the same thing, similarly, we are going to take limits of annuity due. So the notation for perpetuity due is a double dot infinity into I, and we take limit n go to infinity of the annuity due. Remember the formula for annuity due we learned from the first lesson of annuity is 1 minus bn over d. D represents for due, right? So again, v to the n go to 0 when n go to infinity, so this becomes 1 over d. So perpetuity immediate, the price is 1 over I. Perpetuity due, the price is 1 over d. And in perpetuity, we don't have accumulated value because the payment continue forever, so we don't have accumulated values. We should have present value. So these are the two formulas that we need to memorize. If you don't memorize it, you can just simply remember for perpetuity to take limit of annuity. And this is very easy to reproduce the formulas. If in case when you go to the testing room and you forget how to find, you forget the formulas of perpetuity, just remember perpetuity is basically the annuity with infinity payments. So just take the limit and go to infinity. And we have some connection between perpetuity immediate and perpetuity due, just like last video when we learned about annuity immediate and annuity due, we had some connection. So for perpetuity, it's the same thing. We are going to have some connection. The first connection, remember in the last lesson, a double dot of n plus 1 into I is equal to 1 plus an into I. So for this, is also applied for a new perpetuity. So a double dot infinity into I is equal to 1 plus a infinity into I. And a infinity into I is 1 over I. And remember, a double dot into I, infinity into I is 1 over d. So we have one more, 1 over d is 1 plus 1 over I. And from here, we are going to subtract both sides by 1 over I. So we have 1 over d minus 1 over I is 1. And 1 over d is a double dot infinity into I, the perpetuity due with $1 payment. And 1 over I is a infinity I. So we have these 4 important formulas in perpetuities. Okay, so now we are going to work on some tricks to solve some problem concerning annuities and perpetuities. So first trick, annuity immediate of 2n payments is v plus v squared plus dot dot to v to the n plus v to the n plus 1 plus dot dot to v to the 2n. So here we are going to break this series into two parts. The first part containing the first n items. So the first n term is basically an annuity immediate of n payments. Then the next n term is basically a deferred annuity, deferred time n with n payments. So it's v to the n an. So from here, if so this is the first formulas. This is the first trick for you when you work with connection between a of 2n and a of n. Now we consider this ratio a of 2n over an. So a of 2n is basically 1 minus v to the 2n over I. A of n is 1 minus v to the n over I. This is by definition, by formulas of annuity immediate. Here I and I cancel, so we have 1 minus v to the 2n over 1 minus v to the n. And remember, by 1 minus v to the 2n is just 1 minus v to the n times 1 plus v to the n. This is the difference between 2 square in college algebra. So a square minus b square is a minus b times a plus b. And then 1 minus v to the n cancel out with 1 minus v to the n, so we have 1 plus v to the n. Another way to look at this is basically you can bring the whole thing here down here. So a to n over an is just an plus v to the n an over an, so that's 1 plus v to the n. And the ratio of d to annuity dues, using the formulas a double dot to n is just 1 minus v to the 2n over d, and a double dot n is 1 minus v to the n over d, and d with d cancel, so we have the same formulas at here, and this is the same at 2 a of 2n over an. So this formula, this trick is called double dot cancel. So if you have the double dots on the numerator and also the double dot at the denominator, you can cancel them. One more, a of 3n over an. So similarly, if you write this formula down, write this formula out, you have a of 3n over an is 1 plus v to the n plus v to the 2n. So in short, these are the 3 formulas you have to memorize when you come to these things. Okay, so that is everything about today's lesson. And now we are going to work on some problem. The first problem, to accumulate 8,000 at the end of 3n years, deposit of 98 are made at the end of each of the first n years, and 196 at the end of each of the next 2n years. The annual effective rate of interest is I. You are given 1 plus I to the n is 2.0. Determine I. So you see, this problem basically an annuity with block payments. The first period you pay $98. The second period you pay 196. That means increase it by 98. And the question asks for the question gives you accumulated value. So you are going to start at the beginning and move upward, move forward. So using the formula, the short way method, the shortcut methods, we have accumulated value is 98 as 3n. That means we make this 98 the 3n payments. And then the second block is increased by 98. So instead of using 196, we add 98 as 2n. This is the short way. And now we are going to use the formulas of S3n and S2n to determine I. So accumulated value is 8,000. S3n is 1 plus I to the 3n minus 1 over I. And S2n is 1 plus I to the 2n minus 1 over I. So here we have the common denominator is I. Here we have 98 times with, here we have the same 98, so we factor 98 out. 1 plus I to the 3n. Here we are given 1 plus I to the n is 2, so this is 2 cubed. Right, this is 2 cubed. This is a property of exponents. And minus 1 plus I to the 2n is 2 squared, the using property of exponents, minus 1. So we have 8,000 is 980 over I, and I is 0.1225, which means 12.25%. So the answer is C. So that's the first problem. This problem we apply short way method, right? Short way method for annuity with block payments. Problem number 2, a perpetuity immediate pays X per year. Perpetuity immediate, that means we pay X every year at the end of each year, and we continue paying forever. Brian receives the first n payments. Collins receives the next n payments, and Jeff received the remaining payments. Brian's share of present value, the original perpetuity is 40%, and Jeff's share is K, calculate K. So here we are going to use present value of these three people to find K. So let's look at present value of the third person, Brian. So Brian received the first in payment. So basically present value of Brian is just an annuity immediate of end payments. So the present value of Brian is PV1, present value 1 is XAN, because it's basically just annuity immediate of X dollars for its payment continued in years. And Colin's present value is because Colin received the next in payment, so it's called deferred annuity. It deferred time in is considered in payment, so that is V to the N XAN. This is deferred annuity. For Jeff, he received the rate. So we take the whole present value of this perpetuity, subtract what Brian and Colin received. So we have XA infinity, that means the present value of the whole perpetuity subtract XA to N, because the first 2 years, the first 2 N years, the payment was sent to the other two people, so we subtract the amount. So now one more information is given is Brian shares a present value of the original perpetuity is 40%. That means this amount divided by XA infinity is 40%. So since Brian's share is 40%, we have XAN. This is present value of Brian amount. This is equal to 0.4 times present value of the whole perpetuity. And we're going to use the formulas of annuity immediate and perpetuity immediate. So we have 1 plus V to the N over I. Here X and X cancel, that's why we don't have to care about X here. 1 minus V to the N over I, this is AN. This is equal to 0.4 over I, because remember A infinity, the present value A infinity is 1 over I. So from here we can solve for V to the N. I with I cancel. So V to the N is 1 minus 0.4, which is 0.6. So now we have found out V to the N. The question asks for the percentage of Jeff's share. So the percentage of Jeff's share is basically BV3 divided by the present value of the whole perpetuity. The present value of Jeff's share is basically using this, so XA infinity, so this is X over I, minus XA to N, so X times 1 minus V to the 2N over I, and the whole perpetuity present value X over I. So X over I cancel out, you have 1 minus V to the 2N. V to the N is 0.6, so V to the 2N is 0.6 square. So we have this is 1 minus 0.6 square, which is 0.36. So Jeff shares 36% of the perpetuity. So answer D. So that is the second problem. Now we continue working on the third problem. A loan is to be repaid by annual payment continuing forever. So this is perpetuity. The first one due 1 year after the loan is made. Find the amount of loan if the payments are 1 to 3, 1 to 3, 1 to 3, 1 to 3, assuming an annual effective rate of 10%. So here we have something look like perpetuity, but it's not perpetuity immediate, it's not perpetuity due. Basically it's like a perpetuity with unequal payment. And we have the rule 1 and 2 and 3 and come back to 1 and 2 and 3. So we are going to use present value formulas for this. So present value 1 from time 1, because this is due 1 year after the loan is made. So this the first payment is time 1. So we have 1V, then 2V squared, then 3V cubed, then V4, then 2V fifth, then plus 3V to the 6th, and continue. So here the first 3 is a block, the next 3 is another block. If we factor VQ out, we have the same with these 3, right? So we continue factoring out. So this is 1 times v plus 2v squared plus 3v cubed. The second block of 3 items is v cubed times v plus 2v squared plus 3v cubed plus this is v to the 6 and continue. So here we factor v plus 2v squared plus 3v cubed out. We have 1 plus v cubed plus v6 plus v9. Using the geometric series we learned last time, we are going to calculate the present value. So this term, the first factor is the same, v plus 2v squared plus 3v cubed. And the last factor is basically 1 over 1 minus v cubed. And this is and we use v is 1 plus 1.1 to the negative 1 because the effective rate I is 10%. So 1 plus I is 1.1, so v is 1.1 inverse. And we plug in here, we have the present value is 19.366. That means the amount loan is around 19.366, so it's at least 19 but less than 20. So option B. So that's problem number 3. In this problem, we use the formula of geometric series, and we also work on something related to deferred annuity. It's like an annuity deferred times 3, then times 6, and so on. Problem number 4. Annuity X and Y provide the following payment. Annuity X and Y have equal payment, equal present value at annual effective rate of interest, such as v to the 10 is 1/2, determine k. So this is the first annuity, annuity X. The first 10 years is paid $1 at the end of each year. Then the next 10 years is paid $2 at the end of each year, and the last one is $1 at the end of each year. Annuity Y is paid k dollars at the end of each year for the first 10 years, then pay nothing for the next 10 years, and k dollars at the end of each year for the last 10 years. Since the question said like these two annuity have equal present value, so the first step, of course, we are going to evaluate the present value of these two annuity. So for annuity X, present value is, remember using the shortcut, the short way in block payment. This is an example of block payments. So to find present value, we start at the end and moving backward. So the first one is 1. So we have 1 make for 30 years, so we have A30. Then from 1 to 2 is increased by 1, so we add 1 times A20. And then from 2 go back to 1, so we subtract 1 because it's decreased by 1. So this is the present value of annuity X. And we are going to use the formulas of annuity immediate. A30 is 1 minus v to the 30 over I. A20 is 1 minus v to the 20 over I. And A10 is 1 minus V10 over I, and then we simplify using the assumption that V to the 10 is 1/2, so V to the 30 is 1/2 cubed, V to the 20 is 1/2 square, V to the 10 is 1/2. So annuity X present value is 1.125 over I, and we continue working on with present value of annuity Y. So this is similar to annuity X. We start at the last block, so we pay K and use K for 30 years, and then from the third block to the second block it decreases by K, so we subtract K, and then from the second block go back to the first block, we increase it by K, so we add K. So KA30 minus KA20 plus KA10, and using the formulas of annuity immediate, we have K times with 1 minus V to the 30th minus 1 minus V to the 20th plus 1 minus V to the 10. And this is K times 0.625 over I, because V to the 10 is 1/2, so V to the 20 is 1/2 cube, V to the 20 is 1/2 square. So we just plug in. We have this is K times 0.625 over I, and because the question give you one information that these two annuity have the same present value, so we are going to set the two equal and then solve for K. So set the two equal, we cancel I with I, so we have 0.625, K is equal to 1.125, so K is 1.8, which is 9/5, so the answer is E. So in this problem, we apply the shortcut in annuity with block payments. Now we go to the last problem of today, problem number 5. You are given AN is 10, A3N is 24.40. Determine A of 4N. This problem we are going to apply the trick. So first of all, I'm going to make the ratio of A of 3N over AN. So A of 3N over AN is 1 plus V to the N plus V to the 2N, and this is 24.40 over 10, which is 2.44. So this is basically a quadratic equation of V to the N, where V to the 2N plus V to N minus 1.44 is 0. And remember, because V cannot be negative, so we are not going to take negative solution of this equation. So V to the N is nib 1 plus square 1 square minus 4 times 1 times nib 1.44 over 2. This is a quadratic formula. And we have 0.8 for V to the N. And now we are going to determine A of 4N. So A of 4N is basically A of 3N plus V to the 3N times AN. And A of 3N, A3N is 24.40. V to the 3N is basically 0.8 cubed. And AN is 10. So we have 29.52 is the answer for A4N. And answer D. So that is everything for today. Thank you so much for watching, and because annuity is a very huge topic, so I would have to spend a few more videos to finish this. So today I have finished the second video in annuity. Then next video I'm gonna finish one more video in basic annuity, and then we extend the topic to more advanced annuity. So thank you so much for watching, and I hope you guys enjoyed my video, and hope to see you guys next time. Bye bye.